Hey YouTube, what's up? Dr. T here from St. Petersburg, Florida. So let's look at another 2-minute paper about recurrent neural networks, where they are combined with convolutional networks to avail the labeling of the contents of images. Here you're looking at Tampa Bay, which is about 30 miles away from St. Pete, and the third largest city in Florida.
Dear fellow scholars, this is 2-minute papers with Károly Zsolnai Fehér. Neural networks can be used to learn a variety of things, for instance, to classify images, which means that we'd like to find out what breed the dog is that we see on the image. This work uses a combination of two techniques. A neural network variant that is more adapted to the visual mechanisms of humans and is therefore very suitable for processing and classifying images. This variant we call a convolutional neural network. Here's a great web application where you can interactively train your own network and see how it improves at recognizing different things. This is a dataset where the algorithm tries to guess which class these smudgy images are from. If trained for long enough, it can achieve a classification accuracy of around 80%. The current state of the art in research is about 90%, which is just 4% off of humans who have performed the same classification. This is already insanity. We could be done right here, but let's put this on steroids. As you remember from an earlier episode, sentences are not one thing, but they are a sequence of words. Therefore, they can be created by recurrent neural networks. Now, I hope you see where this is going. We have images as an input and sentences as an output. This means that we have an algorithm that is able to look at any image and summarize what is being seen on the image. Buckle up, because you're going to see some wicked results. It can not only recognize a construction worker, it knows that he's in a safety vest and is currently working on the road. It can also recognize that a man is in the act of throwing a ball. A black and white dog jumps over a bar. It is not at all trivial for an algorithm to know what over and under means, because it is only looking at a 2D image that is the representation of the 3D world around us. And there are, of course, hilarious failure cases. Well, a baseball bat? Well, close enough. There's a very entertaining web demo with the algorithm and all kinds of goodies that are linked in the description box. Check them out. The bottom line is that what we thought was science fiction 5 years ago is now reality in machine learning research. And based on how fast this field is advancing, we know that we're still only scratching the surface. Thanks for watching, and I'll see you next time.
This paper relates to the Stanford course CS231, Convolutional Nets for Computer Vision, designed and taught by Andrew Karpathy, while a postgraduate in Fifi Lee's lab, who now happens to work for Google as Director of Computer Vision or some such title. I went through this course last year and it is excellent. It sets the bar, the standard for how computer science classes should be taught, in my opinion. So do check it out. Last but not least, Andrew Karpathy went from completing his PhD at Stanford to work for OpenAI for a short period of time and was subsequently whisked away by Elon Musk. It's one of those prodigies that started it off, as Director of Computer Vision for Tesla Motors, where he currently works. I hope you find this post interesting. Do consider subscribing to the channel, and I will see you next time.